Hello students, now welcome back in Maths online class. So we are going to start the second topic of the chapter, area related to the circle. Okay, so our topic is there, area of sector and segment. So today we will learn in this video how we will find out the area of sector and area of segment. Already we have discussed in previous class what is sector and what is segment. So we will recall it in this video also. Okay, so keep the NCERT book and a notebook with you while attending online class. Okay, so topic. Let's start the topic. Okay, so we are going to find out the area of sector and area of segment. In front of figure it is given there one circle is there and the theta is given here 80 degree from the center and the radius of the circle is 12 centimeter and we need to find out the area of sector. Okay, so we know that the area of circle is pi r square, we know very well. Okay, and what is given here theta and the complete angle that is 360 degree. So formula is there, area of sector is equal to pi r square theta upon 360 because we are going to find out the area of only theta angle, okay, which is covered by theta angle. So area is equal to theta upon 360 into pi r square, otherwise you can say pi r square theta upon 360. Okay, so put the values. Theta is here 80 degree upon 360 into pi, value of pi is 3.14 and radius is 12. Okay, now we have put all the values. Now we will solve these values. So 0 0 will cancel out. Okay, and 4 2 is 8, 4 9 is 36. So solve these all values. After that find out the what the total answer is coming. It is 100.48 centimeter square. It is the area of this given sector. Okay, so I hope so you have understood this question very well. Now another question for you. Now it is area is given for you. Area is equal to 50 centimeter square and radius is 7 centimeter. Now question asking to you, find out theta angle. At which angle? Okay, it is need to ask. Simple thing, again we need to write the formula. Area is equal to theta upon 360 into pi r square. Okay, we have written this formula. Now put the values. Area 50 is given. Okay, theta upon 360 into pi, that is 3.14, and r is given here 7 and square of 7, that is 49. In place of pi you can also you can write here 22 by 7. Okay, now we will do the cross multiply. 50 into 360 upon 3.14 into 49, this will come, otherwise we need to solve directly. After that at last we will find out the theta angle after complete solution. Okay, so it is coming here 50 is equal to theta upon 60 into 3.14 into 49. So 3.14 into 49 and divided by 360. So what will coming? It will come 0.427. So theta is equal to 50 upon 0.427. Okay, to make the calculation easier, we can also put here in place of pi 22 by 7. When we will put the 22 by 7 in that way, 7 will cancel out and our calculation will become easier. Okay, so it is whatever we are solving here, it is also quite okay. So what the theta is coming? Theta is coming 117 degree. Okay, So this was the application of the questions. By this way we will find out the area of sector and area of segment. Segment formula is different here. Segment, you can say sector is a region. Sector is a region inside the circle where we will find out the okay. So this is question same question 80 degree and 12 that you have already solved. Arc length. Now we are going to discuss on arc length. Okay. Area of sector we have find out now. See by the red color which is highlighted. That is the arc length. Okay. In previous class you already studied about the major arc and minor arc. Okay. So what is that? Arc length is a part of circumference or not? Arc length is a part of circumference, and we know that circumference is equal to 2 pi r. The formula is there, theta upon 360 into 2 pi r. What is formula? Theta upon 360 of 2 pi r. Okay. So because arc length is a part of circumference, so theta upon 360 into 2 pi r, so we will put the values 2 into pi into r. Now 80 upon 360, when we will cancel, we can solve it, and pi is 3.14, either 3.14 or 22 by 7, and r is given to us, that is 12 centimeter. Okay, so we are solving this one. So what is the arc length is coming? 16.8 centimeter is the arc length of the given figure. Okay, but if we are going to find out the, it was the arc length of minor arc because with the 30 degree. If we are going to find out the arc length, major arc length, so what we will do? Two images are there. First we will find out the circumference of the circle and minus this one, then we will find out the major. Same question here for you. Now theta is changed only, it is 110 degree, and the arc length is given to you. Arc length is given to you, and you need to find out the radius. So again we will write arc length is equal to theta upon 360 into 2 pi r, theta upon 360 into 2 pi r, and arc length is 20 is equal to theta 110 is there, and upon 360 and 2 pi r. Now 0 cancel out. We will put the value of pi, that is 22 by 7, and do the cross multiplication, either 22 by 7 or 3.14. After when we will solve and do the cross multiplication, so it will 20 into 360 upon 110 into 2 and 7 upon 22. So we will solve this calculation. Okay, otherwise directly we will solve a 110 divided by 360, that is 1.92 into 3.14, that is total complete solution will get at last 1.92. So r is equal to 20 upon 1.92. So it will come approximately, when we will divide it, so it will come 10 point something, it means 10.4 centimeter. What is the r is coming here? 10.4 meter is the r of the given figure. Okay, so two questions of that one. Arc length, in the case of arc length is given, and we are going to find out r or theta. If r, suppose here are the three quantities, arc length and theta and radius. So if two are given, the third, by using this formula easily we can find out. Formula is there of arc length, s is equal to theta upon 360 into 2 pi r.
Okay, so example A asks us to find the area of the blue sector, and we're supposed to just leave our answer in terms of pi. So the first thing we need to do to find the area of this sector is find the area of the entire circle. Now we know that the radius of the circle is 8 units, and the area of a circle is pi times the radius squared. So if it's 8 units for the radius, then we have pi times 8 squared, or 64 pi, as the area of the circle. Now that we know the area of the entire circle, 64 pi, we need to find out what portion of that entire circle's area we have in our little sector right here. So we take a look at the degree measure of the sector we have, 60 degrees. And since our sector is 60 degrees and the entire circle is 360 degrees, we have 60 360ths, or 1/6 of the entire circle. So if the area of the entire circle is 64 pi units, and we have 1/6 of that area, then we have 1/6 of 64 pi. And if we multiply or divide 64 by 6, we get about 10 2/3. So we get about 10 point, oops, that was a bad zero, sorry, 10.66 pi units as the area of our little sector. Yeah, 1/6 of the area of the entire circle, and the area of the entire circle is just the radius squared times pi. That's it. Let's take a look at the next one. Example B. The area of the sector is 8 pi, and the radius of the circle is 12. What's the angle? So now we're going the other way. Now we know the area of this little segment right here. We don't have to calculate it. We don't know the area of the whole circle, but we do know the radius of the circle. So if we find the area of this circle real quick here, we know that it's going to be pi r squared. So it's going to be 12 squared times pi, or 144 pi for the whole circle. We have 8 pi. So if what we have is 8 pi out of 144 pi, what we want to know is, by the same comparison, or in the same ratio, what's x degrees out of the total number of degrees, which is 360. So we have a proportion. The area of the little segment compares to the area of the entire circle, the same way that the degree measure inside compares to the degree measure of the entire circle. So now we can just multiply, and we get 8 pi equals, in fact, we can just cancel the pi's right at the beginning. Not worry about them at all. 8 equals 144x. Oh, I got to cross multiply. Sorry about that. Let's go back that up. We'll go ahead and cancel our pi's anyway, but we'll cross multiply. So we'll do 144x is equal to 8 times 360. 360 times 8, 2880. 2880. Okay, and then we divide both sides by 144. And we get 20. So 20 degrees represents the degree measure of our little segment right here out of the 360 that represents the entire circle, the same way that 8 pi represents the area of the segment, the same way 144 pi represents the area of the whole circle. Cool? All right, let's try example C. All right, for example C here, we need to do a two-step process. The first thing we need to do is find the area of the sector that incorporates the segment we're looking for the actual area of. Our goal is to find the area of just this blue portion here. But the first thing we can find the area of more easily is the area of this entire sector here that's incorporated by this 120 degrees. So what we need to do is find the area of the full circle, and then take 1/3 of it, since 120 degrees is 1/3 of a circle, to find the area of that entire sector down here. So let's start with that. The area of the circle is going to be 24 squared pi units, right? Because it's pi r squared. 24 is our radius. Yeah. So the area of the circle, 24 squared 24 times 24 is 576. So the area of the whole circle is going to be 576 pi square units. Square units. Now, our sector down here is just 1/3 of that because it's only 120 degrees out of the 360 degrees. So if we divide our 576 by 3, divide by 3, then our area of our sector is going to be 192 square units. Yeah, so we took the measure of the sector over 360, that was our 120 over 360, so that knew we had 1/3 of our total. Pi r squared is the area of the whole circle, so 1/3 of 576 gave us 192 square units. Yeah, so 192 square units is the area of a segment of the sector. Okay, so now we know the area of the sector. We need to find the area of the triangle ABC. Now to find that, we got to learn something more than just one side. We do know that it's 120 degrees all the way across the top of this thing. Well, if we were to split this thing in half, right down through the middle right here, and form a 90-degree angle here and here, then that would also split this upper angle in half, and that would give us a 60-degree angle right here, right? Well, if that's a 60-degree angle, then this is a 30-degree angle, because this is a 90. Now we got our 30, 60, 90 triangle again, right? And on a 30, 60, 90 triangle, this side over here would be half of the hypotenuse, so this side over here would be 12 units, and the side down on the bottom would be 12 roots of 3 units, right? So if it's 12 roots of 3 from here to here, then it's 24 roots of 3 from here to here, and it's 12 units from here to here. So now we have a triangle. We're trying to find the area of, we do 1/2 base times height, right? The whole base is 12 times 2 roots of 3. We only want half, so we're just going to stick with our 12 roots of 3. And we're going to take that times 12. So we're going to have 144 roots of 3 as the area of our triangle. The area of our sector was 192 pi. So we're going to have 192 pi minus 144 roots of 3. And if we run all that through a calculator, 192 times 3.14159 gives us 603.19 minus, and then 144 times the square root of 3 is 249.41. So if we then subtract those two, 603.19 minus 249.41, 249.41, we get 353.78. 353.78 353.78 as the area of just our little segment down here that's highlighted in blue. And that one was a little bit of math. Kind of cool. All done.